Welcome to the Air Mapping channel. This channel is dedicated to showing the benefits of using GIS skills along with drone technology. For the purposes of this channel, we will discuss drones under 10 pounds, up to 20 pounds, and over 55 pounds. These are the categories the FAA recognizes. As for my background, I have been a GIS professional for over 17 years and a commercial FAA Part 107 certificated pilot for 9 years. My full-time employment involves mapping the electrical distribution system for the electric utility I work for and flying drones from all 3 categories listed above to inspect this distribution system. I will not claim to know everything, and there are probably better ways to do some of the things I am going to highlight, but I thought it would be a fun channel to showcase the things I have learned over the years. The topic for this video will be the metadata that is in the photos taken with the drone and how to use it. I will go over some basics of the drone and later the basics of GIS when we get to the point of combining the 2 subjects. So let's start with the drone. Did you know when you have a drone, especially a drone from the popular DJI manufacturer, and you use that drone to take video or photos, it writes the X, Y, and Z data to the photo as metadata? What is metadata, you ask, and what is meant by the X, Y, and Z data? Okay, let's take the questions one at a time. First, what is metadata? By definition, metadata is literally data, about data. If you are a GIS professional, metadata is usually associated with a synopsis of the data you are using or publishing. In the drone world, metadata is usually associated with the geographic location of the drone when it took the photo or video in question. Question 2. What is meant by X, Y, and Z? Well, it doesn't mean your fly is open, so rest easy. Simply think of X, Y, Z as the axis in math class. X represents the longitudinal axis of the Earth, and the Y represents the latitude of the Earth. And as for Y, that is the altitude the aircraft was at the time the video or photo was taken. I know what you are thinking. What does that have to do with anything? Great, more useless knowledge. But is it, though? I will share how I use this knowledge in my day job. So, let's take the explanation I gave at the beginning of the video. I said I have mapped the distribution system for an electric utility for over 17 years. What does that have to do with anything, you ask? I know where, within a certain range, all the poles are in the state I live in that my company covers are, and in my state, that's about 90 to 95% of the state, or almost 1.4 million poles. When either myself or another drone pilot for the company takes a photo of damage to the system, I can use the metadata we discussed to overlay that photo as a point on a GIS map and know what pole or equipment on the pole is damaged. As a matter of fact, I can take more than one photo and overlay it on a map, and this is the way my department does an inspection a customer. In this case, the customer is another department in the company, has asked us to do. So, in short, the metadata is the data that describes the location of the drone when a photo or video was taken. We have looked at the metadata, so now let's look at the GIS system. GIS, or Geographic Information Systems, is a complex mapping system started by a company called ESRI, or Economic and Social Research Institute, founded by Jack Dangermond and his wife in 1969, as a software used for conservation tracking, like how much of the rainforest is being eroded away. Today, it is widely used in the utility industry to keep track of water, gas, and electric assets. There are even add-on modules that help keep track of assets in the GIS system, one being the electric module made by Schneider Electric. The module they make keeps up with the electrical model, and if an editor, the GIS professional added to the database, breaks the connection, the model will visually change to show an error. We like to call it railroad tracking. The line will turn gray and have perpendicular red lines in it resembling a railroad track. That way, there is a visual alert to show an error to the editor, who will then have to fix it. So now we know how metadata works from a drone, and we have an understanding of electric utility mapping. Let's put it all together. For this to work correctly, you will have to have a fundamental understanding of the way GIS works and what it can handle as an input. The photos do not magically appear on a map. They come in as points, and the metadata houses the location of the photo itself in the file where the JPEG is. This allows GIS to navigate to that location and open the photo when the point on the map is clicked. Kind of fun, isn't it? Once you have a map of the electrical system, this makes it easy to determine the location of the damage and what asset is damaged. I take this to another level. I will take a data set and make a map for the pilots to edit in the field as they inspect the assets and tell me what is actually wrong with that asset. This is done with an ArcGIS web service. Don't worry, I will talk about this in a later episode. It's basically a picture of the data that can be edited in other programs outside of the GIS platform. I then take the photo points and join them spatially to the asset, meaning wherever the closest asset is to that photo point, all the metadata from the asset joins to the photo metadata. Sounds like it would make an explosion, doesn't it? But something amazing happens. Built inside of GIS is a reporting system that looks at features like the photo points or the assets. When you combine the two features, the report has access to the photo location and the asset issues reported by the pilots in the field. The result: a report with a picture of an asset that is damaged and the details of the damage, and the report in GIS actually exports the photo. The attributes from the asset stating the issue and a map of the location with all the electrical assets and a point at the location where the drone took the photo, all as a line item per damaged asset. This is fun, isn't it? Now I know, not all of you watching aren't map nerds, but I know there are some of you out there watching this that are, and you are just as excited as I am. This has been a very basic explanation of metadata from the standpoint of an electric utility using drone technology to find damage on the system and fix it. If you like this sort of content, like the video, share the video, leave a comment, subscribe to the channel. I will be doing more on drones and GIS in the future. If you'd like to know more, leave me a comment and I will respond. And if you have any suggestions on a GIS and drone topic, leave me a comment. I may just use it. See you in the next video.